Hey you guys, this is Mr. Sal. We're going to look at the Pythagorean Theorem. Thanks for watching. Don't forget to like, subscribe, and comment about the lesson below. Alright, so we'll kind of describe it through a picture on this one. A right triangle, first off, you're going to have two lines that are going to come together like this, which are going to make a right angle. And then we just connect the ends of these two lines like this. Now, again, this is stuff you guys are familiar with. Alright, now as far as you guys know, this is about the extent of a right triangle knowledge that you guys have. However, a right triangle has different parts, which is nice as well. So, the two sides that make up the right angle, this red side and this purple side right here, they are called legs. So, let me define it for you guys on this one. A leg is a side on a right triangle that makes up the right angle. Alright, so we do have that third side on this right triangle, which we need to define, and that's this side. This side is opposite the 90-degree angle. It's kind of like that box is pointing directly at it. But it's just the side that does not make up the right angle, or the 90-degree angle. This is always the longest side on a right triangle. This is called the hypotenuse. So the hypotenuse, we'll define it as the side opposite to the 90-degree angle, which is always the longest side in a right triangle. Alright, and a right triangle, of course, is a triangle made up with one right angle and two acute angles. Which, again, you guys have covered in 7th grade. So this is the key terminology for this lesson. As long as we can understand these three, or know which part of the right triangle we're talking about, then we can do this pretty good. Alright, while you guys finish writing this, I'll just read them. I know an informal proof of the Pythagorean Theorem. I can use the Pythagorean Theorem to find the length of the hypotenuse of a right triangle. We're going to revisit that informal proof even though we just went over it with the squares. So for lesson 15, this one, we're just looking at finding the length of hypotenuse and not the legs yet. That's going to be in lesson 16. Alright, so the Pythagorean Theorem is if I have a right triangle, then I would take the two legs and square them. And if I add those two squares, then I get the hypotenuse squared as well. So this is also known as a squared plus b squared equals c squared. Let's look at what this is actually saying. Since it's the leg multiplied by itself, both times for the red and the purple there, it's just like we're creating a square out of these legs. And if I do that, then I can take the hypotenuse and square it as well, which means I'm actually am making a square out of this thing. So if I took the area of the leg, which would be the leg multiplied by itself, squared, and I added it to the other leg and squared that, then I would have the area of this green square. Well, if I wanted the length of that hypotenuse, then I'm just going to take that green area and square root it. So this is kind of an informal proof, which we did go over with some examples. The Pythagorean Theorem is a famous theorem that is used throughout much of high school mathematics. For that reason, we will see several proofs of the theorem throughout the year and have plenty of practice using it. The first thing to know about the Pythagorean Theorem is what it states. The Pythagorean Theorem. If the lengths of the legs of a right triangle are a and b, then the length of the hypotenuse is c, then a squared plus b squared equals c squared, which is what we just went over. Also, given a right triangle ABC, with c being the vertex of the right angle, then the sides AC and BC are called the legs of triangle ABC, and AB is called the hypotenuse of triangle ABC. Take note of the fact that side A is opposite the angle A, Side B is opposite angle B, and side C is opposite angle C. So for example, if I call this angle B, then the side length B would be opposite of that. Same with A, it's opposite of angle A. And then C, of course, is the hypotenuse, which is opposite the right angle. So here's an example using the Pythagorean theorem directly. And we're going to look at an example like this, but we see that 6 is this leg, 8 is this leg, and we know these are legs because these two make up that right angle right there in green. So what do? I'm going to take the leg and square it, and the other leg, which is 8, and square it, which then gives us 36 plus 64. And the hypotenuse squared is equal to this 100. Now we know we could square root both of these. And if we did, we would get C equals 10. So this length right here is a straight 10. But for right now, if we write the square root of 100, that's going to be okay. Because that would be the length of a side of that square if I were to take that and make it a square out here. Alright, take a moment with your partner or neighbor and see if you can find the length of this hypotenuse of this right triangle. Alright, on this one, let's use the square thing on this one, and then we'll use the actual Pythagorean theorem on the others. So, it's not dividing in half. I took the area of that red square, which is 9, and the area of the purple square, which is 49. I added those two areas together to get 58 in green. The length of that is the square root of 58. That's not a long division symbol. That's a square root radical symbol. We were given the area of that square at 58. So to find the length of that, the side length of that square, we took the square root of that area, which is 58. Determine the length of the hypotenuse of the right triangle shown. Note, figures are not drawn to scale, so measuring isn't going to help us on this one. Alright, we'll try the square thing again to see if we can get that through, because we use that informal proof. And then we'll see if we can find the length of that hypotenuse. Take 1 minute to do that with your partner. Alright, I'm going to use the square thing on this one as well before we look at the Pythagorean theorem directly. So I got this side length, which would make a square or something like this right here. And the area of that square is going to be the side length multiplied by itself. So this area is 9. Then I've got this other side length, which is 4, so I'm going to make a square out of it. So the area of this square is 4 times 4, which is 16. But then I want the area of this square, which is the side length of that hypotenuse right there. So to do that, I take the area of the two smaller squares, 9 and 16, and I add those two together, and that gives me 25. So that's the area of that square though. If I wanted the side length of that square, which is the hypotenuse in this case, I'm going to take the area and square root it. And the square root of 25, which will work for now, but if you guys put that in the calculator, it'll give you a whole value. So if you do put it in the calculator and it gives you a whole value, then keep it. If it gives you a decimal value, it's irrational, which we may get around to talking to later. But the square root of 25 will do in this case because we haven't gone over square roots just yet, except for the small amount we have. Alright, so the answer on this one would be one of these two right now. Alright, so you can still use the squares on these, but I'm going to show it differently on this one. Determine the length of the hypotenuse of the right triangle shown. No, figures are not drawn to scale. Take 1 minute to do that with your partner. Alright, so the Pythagorean theorem, again, you could have used the squares on this, but it's when I take the two legs, I square them, which is why we made squares out of those. If I add them together, then I get the hypotenuse also as a square. Now on this one though, let's set this up. So I'm going to identify this leg right here, which is 8. And then I got this leg right here, which is 11. And the hypotenuse is just shown as c squared. So this is using the equation to do it instead of the pictures, which is okay. 8 to the power of 2, 8 times 8 is 64. So again, that would be the area of that square. 11 to the power of 2, 11 times 11 is 121. When I add those together, I should get the hypotenuse as a square. So 64 plus 121, this would combine to be 185, which equals c squared. But I don't want the area of that square. What I just want is the length of the hypotenuse, c. So to do that, I just square root that 185. So c is the square root of 185. Take a moment and solve this one, number 3, with your neighbor. We'll give you guys 1 minute to do that. Find the length of that hypotenuse. Alright, so I'm going to use the windmill method on this one by showing the squares. So I'd have this leg, and I'm going to make a square out of it. Its area would be 4 times 4, which is 16. Then I've got this leg here. It has a side length of 9, so I'm going to make a square out of it. So that would be 9 times 9, which is 81 square units. So if I take the hypotenuse and make a square out of it, or try, then I don't really need to calculate anything for this one because I'm going to take the leg square, 16, and add the other leg square, which is 81. And that will give me the area of the green square, which is at 97. So then, how do I find the length of this side of that square? All we need to do is take the area, 97, and square root it. And that is the length of the hypotenuse. Now, if you plug that into the calculator, it'll give you 9 point, maybe 8 something. We're not worried about that right now. If it gives you a decimal, just keep the square root as it is. If it gives you a whole value, then write that value in. Number 4, determine the length of the hypotenuse of the right triangle shown. Figures are not drawing to scale. Alright, 1 minute with your partner, go. Alright, I'm going to use the same method as the last one. I've got this length right here, which is a leg. If I make it a square, then it would have an area of 2 times 2, which is 4. Then I got this leg, and if I make a square out of it, something like this, then its area is 5 times 5, which is 25. So if I look at the area of this hypotenuse as a square, it would have an area equal to the two small areas added together, 4 and 25. And that gives me an area on this square of 29 units squared. But I want the length of this hypotenuse, which is the side length of that square. So I take my 29 and I square root it, and then I have the length of that hypotenuse right there. Take 1 minute with your partner and do number 5 here. Find the length of that hypotenuse. Alright, good luck.
No, I'm not going to. Okay, so this one is you do 1 to the squared, and that's just 1. And then this one is 9 to the squared, and it's 81. And then you add them for this. Oh, that was really good. And then, can you erase? It's fine. Okay, 1 plus 81. And then you do equals 82.
Excellent. Alright, so the length of that hypotenuse
Left-handed.
is the square root of 82. Lesson summary really is just the objectives, which is okay, but this is just stating the Pythagorean Theorem for us. It was very nice of them. Alright, for the problem set, for each of the problems below, determine the length of the hypotenuse of the right triangle shown. Note, figures are not drawn to scale, so measuring isn't going to do us any good. Let's just start with number 1. I'm going to do this one a little differently. So instead of drawing the square on this one, we do want to find the hypotenuse. I'm just going to point out this red length is a leg, this purple one is a leg, and the green is the hypotenuse. So if I were to look at the Pythagorean Theorem, if I were to take the square of the legs and add them together, I would get the hypotenuse squared. Now that red length is given to us as 3, and the purple length is given to us as 9. If I square those and add them, then I get the hypotenuse squared, which is just c to the power of 2. So this is how it sets up as an equation for us, which I think is kind of nice. 3 to the power of 2 is 9. 9 to the power of 2 is 81. So when I add these together, once again, I get c squared. So let's go ahead and add these two together. 9 plus 81 is 90. And this is equal to the hypotenuse as a square. So if I wanted just the hypotenuse, I would take that 90 and I would have to square root it. And this would be the length of the hypotenuse right here. Alright, to solve this one, what I'm going to do is I'm going to make a square here. Because this is a leg. And if I can find the area of that square, it can help me find the length of the hypotenuse. So that's 8 times 8, which is 64. Then I've got this other leg right here in purple. And it would have an area of that square, which is 4. So to find the area of this hypotenuse square, something like this, its area would be the 4 plus the 64, which does equal 68. Now that's the area of the square. To find the side length, we're going to take that 68 and we're going to square root it. So this would be the length of the hypotenuse right there, square root of 68. I'm going to use the same method on this one. Here I've got this leg, which is the length of 2. Alright, the area of this square is 2 times 2, which is 4. This length also is a leg, so I'm going to turn it into a square, and it would have an area of 9 times 9, which is 81. So the hypotenuse, if I turn this into a square, then it would have an area of the sum of these two. So adding these two together gives us 85. Now that's the area of the square, but what we really want is the length of that hypotenuse, which is going to be 85, the area, but we're going to square root that. So the square root of 85 is the length of the hypotenuse. Alright, that red one and the purple one are legs. So their lengths are 1 and 7.
What the heck? I just asked.
If I square those, then add those squares, then I should get the hypotenuse squared. So solving this, 1 to the power of 2 is 1 times 1, which is 1. 7 to the power of 2 is 7 times 7, which is 49. So if I wanted the hypotenuse as a square, I would add these two together. 1 plus 49 is 50. But I don't want the square, I would just want the length of the square. I'm going to take that 50 and I'm going to square root it, and that would give me the value of c. The hypotenuse, the length is the square root of 50. Good luck.
Okay. So you do 6, and then that's 36, because you're multiplying it. And then you do 3 times 3, which equals 9. I'm just going to copy the teacher. And then you do 36 plus 9. And that equals to 45. And then you draw a square root sign, and that equals to 45.
Alright, let's do this one.
I got it.
once again, we'll show the squares on this one. So this is a leg, which has an area that square does of 9, 3 times 3. And then this is the other leg, not a good square, but whatever, its area. If it were a square, it would be 16 square units. So the area of this green square, the hypotenuse squared, would be 9 plus 16, which is 25. So if the area is 25, the length of the hypotenuse is that 25, but square rooted. We should be to the point where we can plug this into a calculator. If the calculator gives us a whole value like 5, like it does on this one, then let's circle that answer. On this one, it's the same idea. We got this leg here. We'll make it a square. It has an area of 2 times 2, which is 4. The area of this square also, 4 times 4, which is 16. That's the area of that square. So the hypotenuse, if we were to square it, would be the 4 plus the 16, which is 20. So the length of the hypotenuse is the area, 20, but we're going to take the square root of that. Square root of 20, that is all. Same idea here. This leg would be squared. So its area, 5 times 5 is 25. Then we got this leg. Its area as a square. 12 times 12, 144. So this C value as a square, that area would be 144 plus 25. So the length of the hypotenuse would be the area, 169, but square rooted. And your calculator will tell you this is 13. So since this one, the calculator gives us a whole value, we'll circle that answer. If it's a decimal value, then we keep the square root there. Alright, here we go again. I'm going to do this one a little differently. We'll use the Pythagorean Theorem directly. So I have that leg squared, and then I've got the other leg, 13 squared. If I add these together, I will have the hypotenuse squared, which is our longest length opposite of that right angle. So let's evaluate these. And when I add these together, I get the hypotenuse as a square. So combining these, so from here, if I just wanted the hypotenuse, which is C, not the square of C, then I would take that 233 and square root it. And that would be my answer right here. Let's try using the same method on this one as we did on that last one. So, I'm going to look at the 7, it's the leg. The length of 10 is also a leg, because they make up the right angle. So I've got 7 and 10. When I square these and add those squares, then I get the hypotenuse squared. 7 times 7 is 49. 10 times 10 is 100. So adding these together, I get 149. And this is equal to the hypotenuse as a square. So if I just want the hypotenuse, I'm going to take that 149 and square root it. And that would be my final answer. If I put this in the calculator,
It won't show anything.
it's going to give me a decimal 13 point something,
No.
which, oh, you're right, it'd be 12 point something. Well, as soon as it shows a decimal, we don't want that value. So the square root of 149 will do. Let's do this one with the squares. So we're going to make these squares. This leg, we're going to make it a square. So that'd be 9 times 9, or 9 squared, which is 81. That would be the area there. Then on this one, I've got 12 times 12, which is 144. That's the area. So if I want the hypotenuse as a square, then I'll take the 81 plus 144, which is 225. So the length there will be the area, 225 square rooted. But if we put in the calculator, it'll give us 15. So C equals 15 in this case. Alright, on this one, we use the Pythagorean Theorem. So I've got this length of 1 and this length of 5. as legs. So if I square the legs and then add the two squares, I get the hypotenuse also squared. And 1 squared is 1, 5 squared, 5 times 5 is 25. So add these together and we get c squared. So 1 plus 25 is 26. That equals c squared. So if I just wanted c, I would take that area of that hypotenuse square and square root it. There it is. So here's the objectives again for lesson 15 real quick. I know an informal proof of the Pythagorean Theorem. If we use the squares, it kind of looks like a windmill, so it's called the Windmill Proof. And then I can use the Pythagorean Theorem to find the length of the hypotenuse of a right triangle, which is what we just barely did.